Hello, everyone. Can you hear me? Yes? Perfect. Is it ready? Can we get started? Yep. Yeah? Okay. Hi, everyone. Thanks so much for joining us today. I'm Teresa. I'm one of the product managers working on Lakeflow and focusing on observability specifically. And yeah, just a little disclaimer before, and also since we're at the end of the conference, please make sure you complete the service. This really helps us to know what you want to see more of and make sure we deliver the best experience to everyone attending. Also, as always, a little forward-looking statement. Some of the stuff you'll be seeing is already there today, but there's also a few things that are in the works or will be coming soon. So are you in the right place? I'm going to give you a quick overview of what I'll cover today. First of all, a big disclaimer. This is not a deep dive session to talk about cost observability, but instead what we will be looking into is Lakeflow observability. So I'll tell you all about what does this actually mean. I'm going to give you an overview of the observability toolbox that we offer, and I'm going to try to give you a little bit of an understanding of when we would expect you to use which tool. And finally, you'll also find throughout the presentation some hints here and there on like what's exactly new since the last year, and also what's coming soon. So do definitely also watch out for those. One more little item of housekeeping is I've attached some QR codes on the slides that will take you directly to the documentation of the tools that you see here. But don't worry, all of these slides will also be made available to you after the conference, and even the recording will be on YouTube, so you'll have plenty of chance to go back and kind of like directly go to the documentations for tools you're interested in. So what is Lakeflow? I hope most of you have attended the keynote this morning and you kind of think, yeah, I know what Lakeflow is about. But just to give a really quick recap, Databricks is our unified data engineering offering where we combine connects, so our ingestion offering, with declarative pipelines and jobs for orchestration. Also, one other disclaimer, throughout this presentation, I'll just be calling it pipelines for simplicity, but what this really refers to is declarative pipelines, but also our connect offering, since it builds on top of those. All right, so what do we mean by observability? Like, what problems are we solving, first of all? So if we start on the top, what we mean by discoverability, this is really about organizing and accessing all of your Lakeflow assets really easily. So this could be, for example, because you're developing a new job and you need to jump into a new run, or you want to access some metadata details such as the name, the creator, the runners, etc., from one quick glance. Or maybe you've just recently productionized a new workload and you want to proactively make sure that everything's looking good. Then we go one level deeper. We're going to be talking about monitoring and alerting. So as you productionize your workloads, I'm sure most of you have a bit more of a reactive approach to monitoring. So alerting becomes really important to identify issues. But regardless of your starting point, whether it's more from this discoverability story I mentioned or alerting, monitoring is where you get a little bit more details and you decide, hey, this is a problem I should be looking into in more detail. Once you've decided there is actually a problem at hand, we're going to move on to root cause analysis. So this is really about understanding what went wrong and why. And here we really want to start equipping you with the tools, whether you're debugging an error or solving an optimization problem, that then helps you to kind of like move on to the green stage where all the problems are solved and you can sleep well at night. So how does Lakeflow factor into that? Like, what does Lakeflow observability mean? Probably all of the things I'm talking about sound familiar to you. However, how it's different with Lakeflow is that now that we have this unified data engineering umbrella, we want to provide you with a unified toolbox. So you don't need to say, oh, if I'm using jobs, I need to use this tool. If I'm using pipelines, I need to use another tool. We want to make sure that we provide the same features across all of Lakeflow. And we're not fully there yet, but we've made some great progress over the last year. And we're very excited to also showcase this unification story in today's talk. So to give you a little bit of a roadmap of what exactly we're going to talk about. So we're going to start with discoverability and talk a bit about organizing, managing, and monitoring your own or your team's job from the UI. Then we're going to be talking about getting alerted for issues. We're going to look a little bit into data quality and what tools are available there. Then we're going to go a level deeper into root cause analysis for debugging and optimization. And finally, we're going to take a step back and we're going to talk about monitoring and analyzing historical observability data at scale. And also, a little disclaimer, we have a lot of content to cover today. So the way I'm going to deliver this is we're going to have questions, and I'm going to show you which tools are best to use to answer certain questions. It doesn't mean that this is the only way you can use this tool, but just kind of the main use case. All right, let's jump into that. So first of all, I'm a data engineer. I want to really quickly access the assets I was working on yesterday. So what's the best way I can start? So in this case, it's very likely that you either know the name, or you've recently accessed it, or maybe you favorited it somewhere within the product. So now we have support for all of the Lakeflow assets in the workspace search, so the search bar that you see on top, for recents, which you can access from the sidebar, and finally for favorites. So that makes it really easy from anywhere in the workspace within a few clicks to access your workloads. But what if instead I'm looking for all of my jobs and pipelines that are part of specific projects? There might be many different ways you could be organizing them together. So for that, we have the Lakeflow landing page, or what you might have seen in your UI as the jobs and pipelines list. And this is really allowing you, no matter how you organize your related assets, whether that's using a runners because you have a specific service principal deploying them, or you have tags for your projects, or maybe you favorite them. This is the central entry point where you can kind of do this management and organization and easily filter for kind of the projects you care about. There you can also then access some metadata for each of them, kind of as you see on the screen. So the name, the runners, the owner, some computer information, the last recent 5 runs, to get a little bit of an overview. And also what's really big here as well is that if you're using DB-SQL materialized views and streaming tables, we've heard a lot of feedback that there's a need for better observability. This will also be coming soon. What if instead I actually need to track my executions, and I need to be aware of all of the failures that are happening? In that case, we have the runs list. So the runs is this kind of a log of all of the executions that are going on in your workspace. So depending on what access you have, as an admin, you will be seeing everything here. You have a great visualization on top to give you a quick indication what your failure versus success trends are looking like, and you'll easily be able to identify any kind of peaks. What that's further complemented with is that we have the top 5 error codes. So here you can kind of get a feeling, why are my jobs and pipelines failing? And this is especially great if you want to kind of have a reality check what's happening. So in my example here, there's a lot of concurrent runs happening. So maybe I can fine-tune these settings and make sure I allow for more concurrency if I can do that. Or maybe it's something to do with my cloud resources. So maybe the troubleshooting actually doesn't start within Databricks. And here actually what's super exciting is that we're introducing pipeline support as well coming up soon. So you'll also be able to have the same visibility of all executions in one place for your pipelines. So one use case I want to mention here specifically as well is that customers use this, for example, to identify jobs that are failing repeatedly or retrying all the time with the same errors, especially for these scenarios where you might have to report on failures in production workspaces and really want to reduce that and also reduce costs as a result. So this is available in real time, and you can look back to up to 2 months. However, if you need to go look into more history and trends, we also have system tables, which we'll cover later today, which will give you history for up to a year. All right, so to quickly recap what we've talked about regarding discoverability is you can quickly access your Lakeflow assets from search, recents, and favorites. We have a unified way to organize and access them using the Lakeflow landing page or jobs and pipelines list. And finally, you can see everything that's currently running and identify potential systematic issues using the runs list. All right, so now we've talked about discoverability, but can you tell me when there is a problem? Of course we can. So we also support notifications. You can get alerted, for example, on failure and have that delivered to email or supported webhooks such as Slack or Microsoft Teams, among others. But we also support notifications for long-running jobs or tasks, or when a backlog builds up. This is especially important for streaming use cases where you want to make sure that you're not falling behind. And all of this can be set up using the UI or API. Finally, so if you have pipelines and you have the need to track events even in more granularity than what we provide out of the box, you can also get alerted on those. So for pipelines, we have something which is very powerful, which are the event hooks. So what are these event hooks? So essentially, these are Python functions that are triggered if a certain event happens as your pipeline is executing. And this gives you a lot of customizability for monitoring, alerting, and also integrations with third-party systems, for example. If you don't yet know what the event look is, and this Seems very obscure to you. Don't worry, we're going to be talking about that in a little bit as well, and I'll give you more details. But what are these event hooks in a nutshell? So they're defined in code. You can use them targeting specific event types and states. You can also customize your failure handling by, for example, saying, okay, it's failed so many times in a row, now I don't want it to be triggered anymore. And finally, you can also track the progress using the hook progress event type in the event log. So what we hear very often, of course, we can provide you a lot of tools, but there will always be other additional metrics or custom use cases that individual customers come across. And what we see a lot is that customers are also writing specific custom metrics to their own tables. So how can I monitor those? So we have something called SQL alerts, which is currently in beta, which is extremely powerful for any of those really custom use cases. So as you can see on the screen, you start by defining a SQL query to pull the data that you want to inform your alerting. Then you define a condition to say, based on this data that was retrieved, if this condition was met, I want an alert to be triggered. Then you can schedule evaluations for these at a regular interval. And finally, you can configure notifications on top of those. What's also really powerful is that we provide alert status tracking, meaning that across your alerts, you have an overview of which alerts have been triggered. And also alert history, meaning that for a specific alert, you can go back and look at how often has this been triggered, and is this maybe indicating a more severe underlying issue I need to be looking at. All right, let's recap what we've seen for notifications. So what problems are we solving here? We are firstly immediate out-of-the-box notifications for failures and thresholds that are being exceeded, with very customizable and detailed alerts for pipelines using event hooks. And finally, we also support very custom use cases for alerting using SQL for the scenarios where you either have your own tables that you write custom metrics to, or whether you want to maybe perform some data quality checks. So this is actually a nice segue into data quality here. So how can I make sure that the data my pipeline is producing meets my company's data quality standards? So for pipelines, and again, just to reiterate, this is for declarative pipelines, we have expectations. Expectations are defined as part of the code. And as your pipeline is executing, before the data is written to the table, you can define rules to say what you want to happen in case they're not met. So let's focus on the graph on this slide. So you see I have the raw data, I have my expectations, and then if they fail, there's an action that can be taken. And depending on what this kind of violation of expectation means for your business, you can decide what should happen. Should this just be a warning you can track over time? Should the data be dropped and you can continue processing? Or finally, should this really fail the flow and as a result fail your pipeline update? Some of the common use cases that we see are things like row count validation, detecting missing records, primary key uniqueness, et cetera. There's a lot of applications. But customers get really, really creative with those. I've also, in recent weeks, heard from a lot of customers that use this to try to track data latency by capturing their timestamps and comparing them to each other. You can then also see directly from the UI for each table how you've performed, like how many of your rows actually failed the expectation to give you this visibility. Now, okay, this is great, but this is for my one specific pipeline and before the data is written to a table. Now, what if instead my company has a number of data quality rules that really need to be applied across the board after the data has been written to a table? I'm glad you asked. So we also have a few solutions for this. So some of our colleagues have been working hard, and there are currently 2 products. So we have data profiling, which is GA. This is used to be called Lakehouse monitoring, if that's a name that's more familiar to you. So essentially what this does is it allows you on a table level to define a monitor and your metrics. It will then create a metrics table tracking it for you. And then it will also kind of tell you how you're doing compared to a baseline or previous time window, so you can kind of track these metrics over time. And then of course you can set up alerting and do some visualizations to see how this has been evolving over time. Secondly, we also have solutions for data quality. This is what used to be called anomaly detection until very recently. This is currently in beta. And what you can do here, this is really for monitoring at scale and tightly integrated with Unity Catalog. So here, this is especially focused on detecting anomalies based on data freshness and completeness. And as part of this, there's also data classification, where it can identify sensitive data, columns with sensitive data for you as well. So these are really the tools, if you're like, for example, an admin team and you're trying to find the needle in the haystack, these are some of the tools you would be turning to. So probably this leaves potentially one little gap here, I'm gonna admit. So what if I also need to monitor data for my jobs and not just my pipelines proactively before data is written to a table? So to address this today, there is something called DQX. This is by Databricks Labs at the moment, but it is a popular solution if this is the need that you're trying to address here. It is supported across all of Spark, so batch streaming and declarative pipelines. You can configure it using a configuration file or in code. It very similarly to expectation has warn and error modes, and you can define different actions that should happen. So if something's dropped, marked, or quarantined. So just kind of like a little disclaimer for the people who are looking for something more in that direction. So just a quick recap on data quality. So if you're looking to enforce more domain-specific roles while your data is being processed and before it's written to the table, we have expectations for DLT. And for if you want to do the same for jobs, you could be using DQX, which is a Databricks Labs product. And if you want to monitor at scale, we have data profiling and data quality as additional solutions, which is for after the data has been written to the table. All right, let's change gears a little bit. So we talked a lot about monitoring and finding issues. So let's talk a bit about root cause analysis. And we're gonna start with what I'm gonna say is a very common scenario. So I just found a job which is running for way too long. So how can I drill into this and figure out how I can fix this? So one great starting point, and that's regardless of whether it's your job or your pipeline, since a lot of the pipelines will be scheduled as part of a job, is the timeline view in jobs. So if you have a job with multiple tasks, this kind of like adds to the graph view by adding like an additional dimension of duration. So here you can see an overview and quickly figure out what was the task that was the main offender here. And then we have even an integration with query profiles where you can expand, and you'll see that in my demo in just a moment, even if it's not on the screenshot, you can expand and identify what was the query that was contributing the most to this. So now a good question would be, so Teresa, what do you mean query profiles? So query profiles are a way to visualize and optimize performance. They are supported for SQL and Python code, for serverless jobs, and for pipelines. What they give you is an overview of the different stages and operators that your query is kind of running through, and it provides you metrics around the time spent, the memory, as well as rows. It also highlights the top operator, that's like the longest running operation, to maybe kind of like skip the overall analysis and kind of like right jump to the chase and start troubleshooting. And it also has some really cool features around being shareable, since you can export it and share it with your team. One other thing that I want to mention here as well is that the Gantt chart we've seen is not the only entry point to this. We actually have something called query history, where you see a list of all of your queries. And you could filter down, I only want to see them for serverless jobs, I only want to see them for my pipelines. And this, regardless of the job or the pipeline, allows you to find the queries that are not very performant. And then from there, you can link it back to the job or pipeline and start optimizing as an alternative entry point. All right, so I also have some streaming workloads maybe, and yeah, okay, they're just basically running almost all the time, but so how can I know that I'm falling behind and that maybe my data is not as fresh as it should be? For that specifically, across structured streaming for both jobs and pipelines, we have some streaming metrics for different sources, such as autoloader, Kinesis, but there are a few more that are supported today. And what this allows you to do is it allows you from the UI in a visual way to plot the unprocessed data over time. So you can quickly spot any peaks and kind of like start debugging the issue before it becomes a problem and your end users don't get fresh data. We also do allow alerting on this on the job level so that you set a certain threshold, as I mentioned just a little bit earlier. So no, for streaming, this is just scratching the surface. There's a lot of other metrics that are very, very important to customers, but we're not going to do a deep dive in this session. there's definitely something like the streaming query listener you should be looking into if you're interested in that, or maybe rewatch some of the other sessions that were available throughout the summit to learn more. And I can say at this point that we are definitely also working on improving streaming observability specifically and making more metrics available. All right, so we've talked about things taking longer than expected. We've talked about falling behind. So how can I understand what actually happened if that's not actually my issue? So for that, we have something like, I'm going to call it like a log of all the events that's happened. So for jobs, this is called the job run events. And for pipelines, this is this event log, as I just mentioned a little bit earlier. And we're going to look into what this does now as well. So first, starting off with the job run events. So this is, as I said, just a detailed log of what's been happening with your job and providing you granular insights into the execution. I think the main use case I see here, because customers ask about this all the time, is that you can separate the cluster startup time from execution time from here. Now let's look into the pipeline event log. So the pipeline event log is a structured record of all the events that have been happening during your pipeline execution. It tracks flow progress, metrics, information on data quality, even information on resource utilization. So it's very rich to help you answer some critical questions for monitoring and debugging your pipelines, or even auditing in some cases. So how can you access this event log? So there is a version of the event log in the UI, but it's not as rich and detailed. So we're currently actually working on extracting more information and make it more easily accessible, which will be made available in a new monitoring page for pipelines, which will be released soon. Alternatively, you can query the event log as well. There are some nuances to this, so I'm not going to go into all the details here, but there is also now a new functionality where you can publish the event log to a UC table, which then allows you to build views, to give other users access, and to enable more observability at scale. And as I mentioned, we also want to make more streaming metrics available here. All right, so let's recap on root cause analysis. So we talked a little bit about understanding where something is running longer than expected and how you can pinpoint some performance bottlenecks using query profiles in the timeline view. Secondly, we talked a bit about streaming workloads and how you can kind of like keep track of backlog. And finally, we also talked about how you can get a detailed log capturing the life cycle of either your job or your pipeline. So now I've talked a lot. I've thrown a lot of information at you. So let's put some of this into practice and do a little demo. So first, I'm going to debug a long-running job. So here I've actually, as you can see, received an email alert because my duration threshold has been exceeded. So let's open this in Databricks. All right, so wow, what happened here? This job ran 22 hours. That doesn't look right to me. Thankfully, that was canceled, but I definitely need to investigate that. So here you can immediately see from the overview of the different tasks that my join data task was doing something that doesn't look quite right. Okay, there's a couple of queries that were performing well, but this is the main offender. So now I can, from here, open this in query profiles to access more details. If I open the actual query profile, here you can see, as I mentioned, this visualization of the flow and the different operators where I can switch between the different metrics as well. I need to be transparent here and make a little disclaimer that this is not a very, very realistic query. I did ask ChatGPT to give me the most inefficient query possible, and it did so well that after 22 hours, the query was still running, and I had to manually stop the job. What we have here as well is that, so you can either analyze it visually, or you can just here click on See Longest Operation, which will kind of do some of the work for you as well and highlight what you should be looking into. And what's really cool as well is that here I can also, it even links back to the cell in my notebook. So once I know what the problem is, I can jump directly to the code file and make the necessary changes. So I'm not going to do this optimization right now since it was a fictional query, but let's assume I've now fixed it. And I really want to make sure that this doesn't happen again because nobody wants to have a job that should take 40 minutes run for 22 hours. What I can do now is I can go to the alerts. So I see my duration warning here, but I can add another threshold. So for run duration, but now I'm going to set a timeout. So I'm going to say, when this job runs longer than an hour, I want you to stop it for me, and I want to get an alert on this. I don't want it to just keep running. So this is what I can do to safeguard against this from happening again. All right, so this was demo number 1. Let's now also look at debugging a pipeline error. So we have a little bit of everything. In this case, I have a pipeline. I forgot its name, but I know that it's part of my project. So I'm gonna go to the landing page, and I'm gonna select my important project that I want to proactively monitor. And I see, hey, this has failed. This is not good. I need to kind of like do some investigation and see what's going on here. So what you'll see now, this is already a sneak peek of the new monitoring page, that the issues and warnings have been kind of like brought to the front. I no longer have to dig into the event log to figure out what happened. And what makes this really cool is that if I click on this, I see here was an expectation that we just talked about that wasn't met. And it's so critical that I wanted it to fail this update. And to fix it, I can now go to jump to code. And this is tightly integrated with our new pipeline editor that you've also seen in today's keynote. And actually takes me to the part of my code where this violation was coming from. So I can fix it and rerun the pipeline seamlessly. What you also might notice is that this new monitoring view is much more in line with the new editor experience. So we're very excited to unifying that and also providing more insights, for example, from the event log to our users. Okay, so now let's change gears a little bit. We've kind of like worked our way all the way down to the root cause analysis from the chart we saw in the beginning. But sometimes I have many workspaces that I need to keep an eye on and I want to do analysis on. I don't want to have to do this for every single workspace in isolation. If I want to do that, go deeper into some historical analysis and optimize my usage, for example, I can use system tables. So what are system tables? They live in the system catalog, and they are by default available to admins, but you can, of course, also grant access to other users. And they give you an overview of kind of like all of your jobs, and to some extent pipelines. There's still some parts of it that are in the works for us. So the tables that you see here are currently in public preview. So for jobs and pipelines, these are more the and also job tasks, these are more the metadata tables, where you see things like the ID, the name, the tags, the creator, but we also capture lifecycle events, so if something was modified or deleted. And then we also have additional tables around the run information for more, like error observability, kind of like understanding where you can optimize. And I'm gonna show you what this could look like in more detail in just a moment. So for pipelines, what's coming next is a pipeline update table, so the equivalent of the runs. And also, this event log we mentioned is very powerful, but often we have platform or DevOps teams that need to monitor really at scale across many, many different pipelines. So our goal is to kind of bring the event log information also to system tables and to allow our users to seamlessly monitor at scale for that as well. So you might ask what is the best way to get started. Thankfully, we do provide some dashboards to answer some of the most common questions to get you started, and you can then further customize it based on your needs. So this is the current jobs dashboard. We're working on an updated version to also include pipelines. But since we don't have that just yet, I'm going to talk you through what kind of information you can also expect in the updated version. So first, we will give you some insights around usage and kind of like what are the jobs that are contributing the most to my cost. Then we give you an overview, for example, about your run distribution. So how many jobs were actually failing or succeeding, but over a much longer time frame and across workspaces than what you saw in the runs list from the UI. Finally, we also give you an overview about the termination codes, so you can kind of like understand maybe where there are some systematic issues that need to be further investigated. But that's not all we do. We go a little bit deeper as well. So we help you track spend on failed jobs. And I think that's an important one, because nobody wants jobs to be failing and costing you a lot of money at the same time. So we identify which jobs are failing the most often and costing you the most money. And we go even a little bit more granular, where we say, oh, these are actually the jobs that are retrying a lot that you should be looking into. And it's actually, funny enough, just a customer I was talking to yesterday told me that especially also those hidden errors, where then maybe a retry eventually succeeds, are also really important to ensure you don't accumulate unnecessary costs. Finally, we also give you some health recommendations and cluster analysis. So we will give you insights, maybe if you have jobs that don't have autoscaling turned on, that don't have tags, that are running on an old DBR version, And we also give you some insights on cluster utilization and identify potential cost savings for your jobs. And I think that's probably definitely something everybody cares about. But in case I haven't convinced you enough on system tables, let's have a look at the numbers. I think they really speak for themselves. We've seen really great adoption, and we've cracked the over 3 million queries now. Lakeflow is actually one of the most popular system tables out there. And finally, we talked a lot about this, dissecting data, doing analysis on historical observability data, gaining insights. But the truth is that a lot of our customers also want to do monitoring at scale using this kind of information. So the team has been working very hard on bringing down the latency of system tables. So just in February, there was an improvement the team made, which brought it down from the average latency from 40 minutes to 20. I need to put a little disclaimer here as well that this depends on the region you're in. So if you don't see exactly that, then feel free to reach out. We can take a look, but it might be region dependent. But we're not done yet. We actually want to bring this much, much closer to real time. Finally, let's recap on what we've seen for monitoring and analyzing observability data at scale. So what are we addressing here? So we allow you on the one hand side to, once we have the latency down to your requirements, to monitor at scale. And what we already have today is great information and dashboards to help you do historical analysis on your observability data. I also at this point just have to briefly mention that, of course, there are some customers that really care about cost in general, and they want to track general usage across all of Databricks. This is also possible. There is a usage dashboard you can also look at, which can easily be enabled on the account level. All right, and with that, let me recap a little bit on what we've seen. So we talked a little bit about Lakeflow Observability and what are the different parts that make up Lakeflow. And we've kind of shown that across all of our offering, we do provide discoverability, monitoring, alerting, and root cause analysis, and also monitoring and historical analysis at scale. Yeah, with that, this is what I had for you. I know this is the last day. A lot of these sessions have already happened. But if you want to learn more about related topics around Lakeflow, feel free to check out any of those sessions once they become available online. And with that, that's it for me. We can open it up to any questions.